morning, sir. My name is Chu Jiesheng. Today, I want to present about the Lab 3, Part 1C, Program 1, which is the loop and add. So first, I want to introduce the data. We have the title message, Pro1, Pro2, result message, and total label. All of these are declared as byte. And then the sentence and the from here, I just follow the uh, example output in the PDF. So it already fixed up. And then start hex 1 is the one side length for the hexagon 1. We declare as D word. And start hex 2 is a one side length for the hexagon 2. And parameter hexagon 1 is the total sex length, sex side length for the hexagon 1. And parameter hexagon 2 is a total sex side length for the hexagon 2. And the total parameter is a parameter hexagon 1 plus parameter hexagon 2. All of this we declare as a D word, and then we don't initialize it. And then in the code, we want to, okay, why we declare as D word? Because the instruction need the 32-bit unsigned integer. And then in the code, we move the offset title message into a EDX, means that we move the address of the title message into a EDX. EDX is a register that store the address of the string. So title message here, calculate parameter 2, we move into a EDX, and then we output write string is the output the content of the EDX. And then call CRL is the end line, so move to the next line, and then we will uh we will move the address of prom1 into a EDX. Prom1 is input hexagon 1 into a EDX, and then we output it. And then call read decimal means that we want to wait the user to input the decimal value and then store into a EAX. After it input, it will store in the EAX. So the EAX has the content of the user input, and then we'll move in the side hex 1. Side hex 1 will store the one side length for the hexagon 1. And then we move the address of the prom2, which is input hexagon 2 side length, into the EDX. And then we output it, we wait the user input, and then we store the EAX. We store the value of in the EAX into the side hex 2. Okay, now we want to calculate the parameter hexagon 1 and parameter hexagon 2. So we want to doing the loop 6 times and then add 6 times to calculate the total calculate the parameter. So we need to use the ECX. So we move the 6 into ECX. ECX is the register that used in the loop counter. We move the 6 means that we want to doing a 6 times loop. And then we want to clear the content in the EAX, so move 0 into a EAX. And then we want to move the side hex 1, the value in the side hex 1 into a EBX. So in the first loop, we add the EBX into EAX. So EAX here is 0. We add the side hex 1 into EAX. So it's a 0 plus side hex 1. So loop 1 here, actually, it will do the ECX minus 1 with the ECX decrement 1. Means that initially it's 6. Okay. After doing one loop, it will become 5. Doing 2 loop will become 4. Because each loop, it will decrement 1. And then when the ECS becomes 0, it will break the loop and move the next instruction. So here, it will doing the 6th loop, and then we add 6 times to the EAX with the EBX. So EAX will become side hex 1 plus 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 side hex 1. Actually, it's a side hex 1 times 6. And then we already calculate the EAX, and then we'll move into a parameter hexagon 1. We're doing the same thing in the parameter hexagon 2, so we move to a 6 become EZ, because previously the EZ will become 0 because after the loop 1 is break, and then the EZ will become 0. And we want to put the 6 into ECX again, and then we clear the EX content, and then we'll move the side hex 2 into EBX. Okay, inside a loop, we add 6 times the EBX into the EAX, and then the EAX now has the side hex 2 times 6. So we move the value in the EAX into a parameter hexagon 2. So a parameter hexagon 2 for the value of the EAX. And then we want to calculate the total perimeter, means that uh, perimeter hexagon 1 plus perimeter hexagon 2. So we move the perimeter hexagon 1 into the EAX, and then we add the perimeter hexagon 1 hexagon 2 into a EAX. So we already have the two of this value, sum of two of this value, and then we put this content of EAX into the total perimeter. So total perimeter hold the perimeter hexagon 1 plus perimeter hexagon 2. And then we want to display the result. So we move the address of result message into the EDX, and then output it. Result message is result of the parameter hexagon 1 and 2. We output it, and then we end a new line, end line, and then we move the parameter hexagon 1 into a EAX. Why we want to move into a EAX? Because we want to output the decimal value. If you want to output the decimal value, we need to use the right decimal, this function, and then this function actually is output the content in the register EAX in the decimal. So we we need to move into a EAX and then output it. And then for the parameter hexagon 2, we do the same thing. We move to a EAX and output it in the decimal. And then we want to output a total label. So we move the address of total label into a EDX, because total label is the string, is a sentence. So we move the total label into the EDX, and then we output it, and then we move the total parameter value in the uh, uh into the EAX, and then we output the total parameter in the decimal. And so is my whole program, and then I will try to debug it, see the result. So this is an example output. We put the 12 for hexagon 1, and put the 13 for hexagon 2. And then we see the result, the parameter hexagon 1 and 2 is 72 and 78. How we got the 72 means that 70, 12 times 6, when we got the 72, and 13 times 6, we got the 78. And the total parameter hexagon 1 and 2 is the 2 of 72 plus 78, so we got the 150. So that's all for me for the program 1. Thank you.